we have learnt about now we have learned about resolution in proposition and first order logic. Now we are going to learn about deductive retrieval system. Okay, what do you mean by deductive retrieval system? Fine. What is the need of it? Okay, and what is backward chaining with respect to it? This is what we need to see. Okay, so these all things we've covered, right? One second. Further, okay, so we need to see what is deductive retrieval. Okay, a generalization of a simple, okay, now first why we need to study is our question. Okay, so we have knowledge based systems, so in knowledge based system and inference system, so we have seen like knowledge base is there, and using knowledge base we try to retrieve certain inferences, right? So for that we have inference engine also. This is what we already know. Now we have automated reasoning systems. So under that we have theorem provers, like automatically they will do reasoning for you, they will derive conclusion for you, these systems. Okay, so theorem provers we have, deductive retrieval systems we have, production systems we have, and semantic networks we have. Okay, so these are the various ways through which automated reasoning is done. Okay, so deductive retrieval, which is our next topic of syllabus, it is the part of the system. Okay, so this system is based on rules. Okay, it proves the theorems using forward backward chaining. So we have backward chaining in our syllabus. Let us do it. So what is deductive retrieval? A generalization of simple data retrieval. Okay, now what your deductive retriever is going to do is, it does the following operation. It stores the rules in database. Okay, so it adds the rules to your database or your knowledge base, and using those rules it finds the answers to the queries whatever asked, and depending upon that answers it generates new rules, and then it adds those rules also. Okay, so using the previous rules already added to knowledge base, it uses those rules and it infers the answers to the queries. We can ask queries. Okay, so already whatever assertions or statements are there in the database, it generates few new conclusions and it can add it to them. Okay, deductive retrieval has three major steps in the processing. One is unification, the other one is backward chaining, and the third one is backtracking. So let us see them. So unification is nothing but generalized pattern matching. So I hope you have understood what is this deductive retrieval going to do. It is going to retrieve from existing data, it is going to retrieve other facts, and these facts also it is going to add. Okay, so again we can say it is inference system. So it uses unification. Unification uses pattern matching. So first of all we need to understand what do you mean by pattern matching. So check here, in question mark X savannah with in tiger savannah. Now what is in question mark X is nothing but the variable. Okay, I'm asking whether this is there in savannah. Okay, so question mark X is nothing but savannah variable. Okay, it is nothing but a variable. So what is this going to return? It is going to return any query is going to return you list of variable comma value pairs. Okay, it is going to return like this is a variable, this is value. Okay, so it compares, this statement is compared, matched with this statement. So what it will retrieve, variable is X, answer is tiger. So it will retrieve you variable X and it will return you the value tiger. Okay, this is nothing but pattern matching. Secondly, what do you mean by unification? It allows pattern to match a pattern. Okay, I can match the pattern with the help of unification. What do you mean by assertions and rules? Assertions are nothing but the simple statements. Okay, simple statements are there. They are stored with the help of this variable called, not variable, we can call it as keyword tell. It is a keyword. Okay, tell. Simple assertions are there, that is nothing but simple sentences. So in tiger savannah is a simple sentence. Secondly, you have backward chaining, and thirdly you have forward chaining. Now see, what do you mean by backward chaining? I'll just explain you with the help of simple example. Whether X is there in savannah, whether the variable X is there in savannah. Okay, if it is there, then whether the variable x is near grass means if it is there in savanna, that means that the variable x is near grass. So if it is there in savanna, it is near grass. I come backward, okay, and forward we talk like this. X is predator of y. X is predator of y. That means y is prey of x. X is predator of y. That is x eats y. That means y is eaten by x. It is like that. So we go forward. Here we go backward. We will see backward chaining further. Okay. So what do you mean by simple assertions? That is simple statements. Then we have backward chaining and we have forward chaining. Okay. Logical terms. What are logical terms? Okay, these are simple things what we should know. Simple constants we have, like tiger is a constant. We have variables. X is a variable. Here variable has to come, like question mark has to precede the variable. Next we have functional term, like father of. So functional name, father of John is a functional name. Okay, whatever functions you find. Okay, now let us see various queries in it. Okay, answering a query. A query is asked by typing ask query. Okay, whatever query you want to ask, you have to type the word ask. Ask followed by query. Okay, so let us ask. Ask. See, these are the syntax for this is syntax for deductive retrieval. Okay, what I need to do is add ask at tiger savanna. So what am I asking? I'm asking if tiger is at savanna. So it is yes no type of question. I'm asking is tiger at savanna. Okay, so what is my variable over here? Tiger. Fine. So it is actually constant over here. Okay, I cannot say it is variable. It's a constant over here. I can also, okay. Now this is the way I'm asking. Yet my query is not answered. We will see how the query will be answered. Okay. One second. This is the way how we can ask the query. We will see further how to answer this query or how this particular query will be addressed. That we'll see in our further slides. So here what we have seen is, what we have learned is how the system will be asking a query. I want to ask that whether tiger is at savanna. So this is the way to ask it. Further we are learning backward chaining is going to help us to retrieve the solution to our query. So let us see what do you mean by backward chaining. So what is backward chaining? It's a goal driven approach. What I have to do is I have to start with my goal. What do I want to retrieve? I have to start with my query, okay, and move from goal backward towards the fact. Okay, so we have to start from our query and we have to go backward. If the query is true, we need to halt. Else we need to find implications that infer the query. If all the premises of these implications are true, I need to infer that the query is true. It uses relevant facts. Okay. So let us see how to do with these examples. So now I'm asking one more query, that whether tiger is near grass. So what is my query? My query is near tiger grass. So my query is I want to ask whether tiger is near grass. Now, before addressing this particular query, I want to say you something, that we have knowledge base. Okay, I said you like how this query will be answered. Okay, so you have knowledge base. Okay, already stored with you. In your knowledge base, you have different assertions. We have learned it in our previous slide, that assertions, that is simple statements or rules are there. Rules for forward chaining, rule for backward chaining. So here I am having my knowledge base. I also said you that knowledge base is stored with the help of word tell. It is stored with the help of keyword tell. Okay, so this is my knowledge base which is already stored. So what is there in my knowledge base? So a simple assertion is there that tiger is at savanna. This assertion is stored. So what was my previous query fired? My previous query was asking whether tiger is at savanna. So what it will do, that query will be matched, pattern matching will be done with this query. And what answer it will get? Yes. Answer is yes. It's that simple. Okay, it immediately gets matching. Fine, because it was a straightforward query. Secondly, in my knowledge base, what is stored? Tell that tiger is at savanna. Okay, tiger is near grass. That particular variable, not tiger, variable is near grass. So it says that, see, I have to come backward, right? So if tiger is at savanna, it says that tiger is near grass. It's like that. Okay. So what is my question now? My question is whether tiger is near grass. Okay, my question is whether tiger is near grass. So it will first of all come. Retriever will first of all check where tiger is at savanna. What it will understand, that tiger is at the savanna. So this it understood. So further it went to here. It went over here. So it already knows that tiger is at savanna. Already this part is true. So then it will go backward. So it will say that tiger, because tiger is at savanna, tiger is near grass. And what will be the answer to the query asked? Yes, true. Tiger is near grass. Okay. In this fashion, the answer is given using tell, ask or retrieved. It was inferred using backward chaining. Something is near grass if it is in savanna. So tiger is at savanna and therefore it is near grass. Okay. If this is true, backward chaining says that if this clause is true, this clause is also true. So your query returned the answer yes by going in backward fashion. Okay. Let us ask one more query. Now our query is, can tiger, this is my query, ask, can bite tiger grass. So the query is, can tiger bite the grass? Okay. So can bite is the function, tiger and grass are the objects. Okay. So the question is, can tiger bite the grass? Now about bite grass, there is nothing in our, nothing was there in knowledge base right now. To add a rule in knowledge base. So there is one rule added in the knowledge base with respect to can bite. So it is can bite x comma y, that is x can bite y if x is near y. So this rule is added to my knowledge base. Previous all rules are same. A new rule is added to knowledge base. Okay, we need to increase our functions. Okay, vocabulary we need to increase. So new rule is added to it, that a tiger can bite the grass if it is near the grass, something like that. Okay. So let us see. Let us ask the question. Ask, can bite tiger grass. So now how this will be working. Okay. So how it will be working? It will find the rule that work. Retrieval will work in this fashion. Okay. The retrieval found a rule that said that tiger could bite the grass. Tiger could bite the grass if it is near the grass. So what does the rule says? Tiger is near the grass and therefore it can bite the grass. Secondly, it found the rule that if tiger is at savanna, it is near the grass. So next it got the answer to this question, right? So if it is if it is at savanna, it is near the grass. Finally, it found the statement, assertion that tiger is at savanna, and therefore it returned yes for the answer that it can bite the grass. See how it went is, it went in reverse fashion. Tiger can bite the grass because, okay, we are doing like backward chaining, right? Chaining is backward, right? Now can bite tiger grass. Now retriever is not doing anything, so it goes to the knowledge base. So it will find the rule with respect to can bite. What is the rule with respect to can bite is over here. It comes to this rule, okay, which says that if tiger is near grass, it can bite, tiger can bite the grass. Okay, this is what. So it reached to this particular rule. Okay, now what is rule used over here? Near, and hence it will go to this near wala rule. Okay, it comes over here, near rule. So now here what does it find? What does the rule says? If tiger is at savanna, it is near the grass. So again, what new thing it explored over here is the word savanna. So finally it comes to the statement which is having the word savanna, which says that tiger is at savanna. So everything gets cleared and finally it says yes, tiger can bite. So in this fashion it has done backward chaining. Okay, I hope it is clear. Further we have backtracking. Okay, what do you mean by backtracking? Now let us ask the question to be retrieval. We will better do with the example. Now already you know what is backtracking, right? Backing up process. Okay, let us see how to do it. Let us ask the question to a retriever. Ask, can satisfy hunger with tiger question mark x. Okay, so now what I want to ask is, can tiger satisfy his hunger with whatever variable I'll be passing. Okay, so how it will work? Retrieval will find something which is called as eats. Okay, means the query has whether it can satisfy hunger. It is related to eating of tiger, right now. So eating of the tiger means in our knowledge base with respect to eating we have the word predator, right? So tiger is predator of what? Okay, of that particular is prey of tiger. It will go to that query of knowledge base, right? Where is our query? Not query, it will go to that statement of knowledge base, that fact of knowledge base. Okay, so here I understand that tiger, it is forward chaining, huh? So I understand that tiger is predator for whatever. So I'll fire this query, and using this query I'll get the answer. For example, I got zebra retrieved, zebra gets retrieved. Okay, so the next query will be asked by the retriever. It is intelligent, huh? Next query asked will be whether zebra is near tiger. Only if it is near tiger, then and then tiger can eat zebra, right now. So it will check whether zebra is near tiger. Fine. So it will ask if zebra is near tiger. So now assume that zebra is not near tiger. So because zebra is not near tiger, this query will fail. Okay, it will return no. Answer return will be no. Again it will ask what is the predator of tiger. Find another predator of tiger. Suppose it returns, the query returns me antelope. Okay, so again the your retriever will ask the query that whether tiger is near the antelope. Okay, let us assume that tiger is near the antelope. Okay, so retriever, now it is near antelope and therefore it says yes. So your query, can tiger satisfy the hunger like with antelope? Yes, it will return yes, because antelope is near tiger. Means in order to do this I had to fire number of queries. Okay, and while I was doing this, first time I tried to do it with respect to zebra. Zebra query got failed, right? It retrieved me no. Okay, so at that moment retriever had to back up and look for answer to the other query. Okay, then it had to find other prey of other prey for this tiger. Okay, so it need to fire other query. When it got the message that it was failed, like it went to in case of zebra it was failed, so at that time it fired other query. So while firing other query, okay, other query again, the predator of tiger again I'm doing. First time I had done it, I got the answer as zebra. Second time I did it again. Okay, so this is called as backtracking. Okay, and while doing backtracking I had to, retriever has to back up and then look for answer for the previous query again. Okay, so this is called as backtracking. Fine, I hope it is clear. So the backing up process or undoing one possible match when it doesn't pan out, right, it is called as backtracking. So basically backtracking means writing your code to try all possibilities because your code isn't that smart enough. Okay, this is generally we are talking about backtracking, but retriever dominantly uses backtracking. Like when the query fails over here, again it goes to the previous query and it runs it. That is called as backtracking. I hope this point is clear. Thank you.